Hi kids, today our topic of discussion is rectilinear figures. First of all, let us see what do you mean by rectilinear figures. In simple term, we can say closed figure bounded by straight lines. That is your rectilinear figure. For example, if you have three sides, it's a triangle. If the closed figure has four sides, it's a quadrilateral. If it has five sides, suppose, it's a pentagon. Suppose six side, it's a hexagon. Similarly, seven side heptagon, and it goes on. Now let us discuss few special cases of quadrilateral, special types of quadrilateral. Now first I'll talk about parallelogram. Now parallelogram. So what is a parallelogram? It's a quadrilateral in which opposite sides are parallel and equal. So that's a parallelogram. Suppose we take a parallelogram like this: A, B, C, D. Then AB will be parallel to DC and BC will be parallel to AD, and they will be equal also, which means AB will be equal to DC and BC will be equal to AD. That's a parallelogram. Now second, we'll talk about a rectangle. So when you talk about a rectangle, it's a parallelogram. It's a parallelogram in which one of the angle is 90 degree, in which one of the angle is 90 degree. So the figure looks something like this. Look over here: A, B, C, D. And if one angle is 90 degree, all the angles are 90 degree. Okay, and AB equals to DC as well as parallel, and BC equals to AD as well as parallel. So that's a rectangle. Now when you talk about a square is a special case of a rectangle only in which the adjacent sides are equal. Rectangle having adjacent sides equal, which means it looks something like this. Look over here, all the sides are equal, okay, as well as the angles are 90 degree. So we have talked about parallelogram, rectangle, square. Now let us see a rhombus. Now when we talk about a rhombus, it's a parallelogram. It's a parallelogram in which adjacent sides are equal. Adjacent sides are equal. So if I can draw the diagram, look over here, something like this: A, B, C, D. This is of course parallel, since it is a parallelogram, and this side is equal to this side and this side. So all the sides are equal. That's a rhombus. Now let us talk about kite. In kite, it's a quadrilateral. It's not a parallelogram. Be careful. It's a quadrilateral in which two pairs of adjacent sides are equal, which means if I can draw the diagram, just look over here. A, B, C, D. AB is equal to BC and AD is equal to DC. That's a kite. One more figure. Space is here. Just look. I'm talking about trapezium. In trapezium, what happens? One pair of opposite sides are parallel to each other. Okay? It's a quadrilateral only with one pair of parallel sides. Which means if I can draw the diagram, just look over here. Suppose see. Just a second. Yeah. A, B, C, D. Look over here. Clearly, AB is parallel to DC. So this kind of quadrilateral is known as a trapezium. And in case if AD is equal to BC, if the non-parallel sides are equal, then it is known as isosceles trapezium. Isosceles trapezium. When AD is equal to BC. Now let us look at some properties of these quadrilaterals. First of all, let us discuss the properties of a parallelogram. First one, both pairs of opposite sides are equal, which means if ABCD is a parallelogram, then AB is equal to DC and BC is equal to AD. Done? Second one, both pairs of opposite angles are equal, which means angle A and angle C are equal, angle D and angle B are equal. How can you prove that? Just look over here. Angle A plus angle D is 180 co-interior. Just look. Angle A plus angle D is 180. Similarly, I can write angle D plus angle C is 180. Angle D plus angle C is 180 co-interior. Which means I can simply say by these two, angle A plus angle D is equal to angle D plus angle C. This cancels out. So angle A equals to angle C. Isn't it? Similarly, we can prove that angle B is equal to angle D. Done. Now, a quadrilateral is a parallelogram if a pair of opposite sides are equal and parallel. Which means for a given quadrilateral, okay, A, B, C, D. Remember this. If you are supposed to prove that this is a parallelogram, just you need to prove that AB is equal to DC and AB is parallel to DC. One pair of opposite sides are equal and parallel. Then only our work is done, which means this quadrilateral is a parallelogram. Remember this, okay? Now, number D. The diagonal of a parallelogram bisect each other and bisects the parallelogram. Which simply means the diagonal. See, this is the diagonal. Suppose this is O. The diagonal of a parallelogram bisect each other, which means we need to prove that DO is equal to OB and AO is equal to OC and bisects the parallelogram, which means see the diagonal, suppose BD bisects the parallelogram into two triangles. See ABD, triangle ABD. We need to prove that this is congruent to triangle DBC. DBC. That is the meaning. The first part, just look, very easy. I need to prove this. Two triangles are congruent. Just see triangle AOB and triangle DOC. This angle and this angle are equal, isn't it? Alternate angle. Angle ABO is equal to angle CDO. CDO, alternate angle. Similarly, this angle and this angle will be equal, vertically opposite angle, which means BOA, angle BOA is equal to DOC. DOC, that's vertically opposite angle. And AB is equal to CD. AB equals to CD. We know this, which means triangle AOB is congruent to triangle DOC, and the reason is angle side. And if these two triangles are congruent, we can say that OD is equal to OB CPCT. Similarly, AO equals to OC, and that's CPCT. Done. And how do you prove that the diagonal bisects the parallelogram? Which means we need to prove that ABD and DBC, they are congruent to each other. Very easy. Just I'll drop this line. See. Now, these two triangles. This angle is equal to this angle. No doubt in that. This is alternate angle. Okay. Similarly, this angle will be equal to this angle, alternate angle, and DB is equal to DB common, which means by angle side angle property, we can prove that these two triangles are congruent to each other. Done. Now let us see properties of another quadrilateral. Now let us look at the properties of a rectangle. The first one, diagonals are equal, which means AC and BD are equal. How do you prove that? Very easy. Take triangle ABD. Triangle ABD. You will see that this triangle is congruent to triangle ABC. ABC. How? AD equals to BC. AB is common and angle A is equal to angle B. So side angle side. So they are congruent, and if they are congruent, then BD will be equal to AC by CPCT. Done. Remember this property, very important. Next, that if the diagonal of a parallelogram are equal, whenever in case of a parallelogram, if the diagonals are equal, it has to be a rectangle. Okay, at times we need to prove that given parallelogram is a rectangle. How do you prove? Just prove that the diagonals are equal. Now, properties of a square. Diagonals are equal and cut each other at right angles. Now, diagonals are equal in the same fashion. We'll prove that ABD and ABC will be congruent side angle side, which means AC will be equal to BD. They are equal, and we know that the diagonal bisect each other in case of a square or in case of a parallelogram. We know this. Now, how to prove that the diagonals cut each other at 90 degree? Which means, look over here, I'll tell you. Cut each other at 90 degree. Which means this is 90 degree. We need to prove that this angle is 90 degree. Just look over here. These two triangles, if you look carefully, DC is equal to BC. Triangle I'm talking about DOC is congruent to triangle BOC. I'm going to prove that. How? Just look over here. This and this side is equal. Okay. OC is common and OD is equal to OB, which means these two triangles are congruent to each other, side, side, side. And if these two triangles are congruent, these two angles will be equal. And suppose this is X and this is Y. These are linear pair. So X plus Y equals to 180. And both the angles are equal. So I can write X plus X equals to 180, which means X equals to 90 degree. Which means the diagonals are equal and cut each other at 90 degree. Next, if the diagonals of a parallelogram are equal and cut at right angles, the parallelogram is a square. We need this in proving sum where you need to prove that a given parallelogram is a square. Just prove that the diagonals are equal and they cut each other at 90 degree. Then look at the properties of a rhombus. The first one, the angle of a rhombus are bisected by the diagonal, which means in this figure, this angle and this angle will be equal. This angle and this angle will be equal. This angle and this angle will be equal. Is it clear? The angles are bisected by the diagonal. We can prove by congruency. Okay. Next, the diagonal of a rhombus cut at 90 degree, which means this is 90 degree. Again, we can prove that these two triangles are congruent, similar to this. Okay. Then these two angles will be equal, this one and this one. So they will add to give 180, which means both the angles will be 90 degree, which means the diagonal of a rhombus cut at a right angle. Now, if the diagonal of a parallelogram cut at right angles, the parallelogram is a rhombus. So in case you need to prove that given parallelogram is a rhombus, you need to follow this. Okay. Now let us look at the properties of kite and trapezium. Now let us see the properties of an isosceles trapezium. Again, when I talk about isosceles trapezium, which means it's a quadrilateral only, in which one pair of opposite sides are parallel to each other and the other pair is non-parallel. And if the non-parallel sides are equal, that's known as isosceles trapezium. So in an isosceles trapezium, I've drawn A, B, C, D. See, angle A will be equal to angle B. Similarly, angle D and angle C will be equal. That's the first property. Okay. The second one, the diagonals AC and BD will be equal in length. We can prove by congruency. And next, OA is equal to OB and OC will be equal to OD. Remember that, okay? That's the properties of a isosceles trapezium. When we'll do the sums, we'll use the properties. Then properties of a kite. We know in see, I've drawn a kite ABCD where AB and BC are equal. Two pairs of adjacent sides are equal. CD and AD are equal. So in this case, the diagonal BD bisects angle B. So this diagonal, BD bisects angle B into two equal halves, which means this angle and this angle will be equal. And it bisects angle D also, which means this angle and this angle will be equal. The first property. Second, the diagonals are perpendicular to each other, which means AC and BD are perpendicular to each other, which means AOD is 90 degree. Done. Then angle A is equal to angle C, which means this angle and this angle are equal in magnitude. And the last one, the fourth one, OA is equal to OC. OA is equal to OC. Okay, we can prove this by congruency. Okay, and the last one, diagonal BD divides the kite into two congruent triangles. See, by diagonal BD divides the kite into two triangles ABD and DBC, and they both are congruent to each other, which we can prove by, I think, side axiom. Okay, so in this video, keep it till here. In the next video, we'll solve sums from this chapter using all the properties which I have discussed today. Till then, take care.